All right. So the hyperbolic function. So where does all this madness come from? Well, it comes from this, right? So here, instead of having x squared, so for the, let's see if I can say it. I'll go ahead and do this a little bit on the paper. Probably should have just made it part of the notes, but that's fine. So the normal trig functions come from the unit circle, x squared plus y squared equals to 1. You have the unit circle. And then here you have this. And here you have, and you defined, and everything's defined off the unit circle. The hyperbolic functions are defined from x minus x squared minus x squared minus y squared equal to 1. Which looks, which looks like this, right? And here we define the cosine as this distance and the hyperbolic sine as this distance, right? And we just build everything from this. And so here are the hyperbolic functions. And we just build, and it just gets really complicated really fast if you just do all this other stuff. But we'll try to keep this as simple as possible. And so your book will officially define your hyperbolic. So hyperbolic sine is, let me just quickly sketch this in. And so this is the cosine, this is the sine. So here, sine of your angle gives you this, right? And this is the cosine of the angle. Why? Because we set this equal to 1, right? And so it's just that ratio. And so here, hyperbolic sine is given by this. Hyperbolic cosine is given by the following. And we'll just sketch the graph of the hyperbolics real quick. So you saw them, but let's actually just sketch it real quick. So hyperbolic sine kind of goes like this. And hyperbolic cosine goes like this. Okay. And so those are the two graphs. You really need to know them now, but I showed you all of them briefly, and then tangent goes through the middle. And notice here from the formula, notice that hyperbolic sine as if x is positive, right? So here, so e to anything is positive, right? We established that, right? E to anything is positive, right? Because there's the graph. So here, if it's a negative x, it'll be flipped this way, right? And so this part will dominate and becomes negative. And here for it's positive, this part dominates, becomes positive. Here, it's always positive, and it just depends on which one is really, really large and which one's really small. So one of these terms will be really large, one of them will be really small. And then we just define the rest of the functions, the hyperbolic functions, as follows. Okay. But what we really care about for this class is the derivatives, right? So, and the derivatives end up being quite nice, per se, because here, hyperbolic sine turns into hyperbolic cosine turns into hyperbolic sine. And so these really look a lot like their counterparts. Hyperbolic tangent is equal to hyperbolic secant squared, and then cosecant is equal to cosecant, hyperbolic cosecant, or hyperbolic cotangent. Sometimes you'll hear you'll hear cot and cosh and or cosh and cinch with an H and kind of H sound on it. I kind of mumble anyway, so I always say hyperbolic. To clarify, that's what I want. It's just how I do it. So So what you're going to do, what you guys care about is just, performing, um, you know, performing some stuff like differentiate. So if I ever want to differentiate this, we're going to do the same thing we did last time. Let's make this F. Let's make this G. I certainly didn't leave myself very much room, but I don't think we'll need it. So F is equal to X, F prime is equal to 1, G is equal to the sinh of X squared, and G prime, so it'd be the derivative of this, which is co. So hyperbolic cosine of X squared, and then the derivative of the inside, because of chain rule, would be 2X. Let me just put it all together. So we'll have, I'll have F prime G plus, oops, I should do this consistently the same way. G prime. So here, X G prime would be 2x squared. So the x times the 2x give me 2x squared. Hyperbolic cosine of x squared plus 1 times g. So we just sine hyperbolic sine of x squared. Okay. Oh, thank you. F prime g. Thank you. So it should be f g prime plus f prime g. And so the only thing you really need to worry about is, well, how do I take this derivative? And just use the normal derivative rules to solve for your normal things. Okay, so I'll leave that up for a second. All right. So let's look at some of the identities. So in order to do some stuff, it's nice just to use some of the identities. We'll do one or two of the proofs just real quick so you get used to proofs. So these are the even odd identities. And so notice here that this is an even function and this is an odd function. And so this is just saying this is the odd identity. So hyperbolic sine is odd and hyperbolic cosine is even. That's the same as true for sine and cosine. So these are the same. So if you plug in negative x, you get just negative of this function, and cosine, if you plug in negative x, you just get back the normal function. Here, instead of sine squared plus cosine squared equals to 1, this is hyperbolic cosine squared plus minus hyperbolic sine squared is equal to 1. And the same thing here, instead of the plus, it's a minus. And here's our double angle formula. And so we have, and so here if we have x plus y, this is how it all falls out. Okay. And these look alike. So the identities are really similar, but they're not always exactly similar. So let's just do some of the proofs real quick. So let me just show you how you'd prove something like this. So let's prove this. The book will ask you to do one or two proofs, so let's just go through it. So let's just do this. Do I know what this or this is? Yeah, I know what this or this is. This is, from here, it's that, so hyperbolic sine is this, hyperbolic cosine is this. So all we're going to do is just plug that in real quick. So we're going to have e to the x plus e to the minus x over 2 squared minus e to the x minus e to the minus x over 2 squared. And we're going to just set that equal to 1. We're going to do a first. All right, so let's go ahead and pull in that 2. Let's go ahead and pull in that square. Now notice I got to be very, 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 very careful here. And let me do e to the x plus e to the minus x squared does not equal e to the x squared plus e to the minus x squared, which you'd be tempted to do. You'd be very tempted to do. Do not do this. e to the, oops, I'm on the wrong layer. E to the x squared is equal to e to the x squared, so that'd be a 2 on it. And then it'd be this times this, and this times this, because you have to FOIL like before, so that gives me a 2. And then be e to the minus plus e to the minus 2x, because it'd be this times this. So it'd be, write it as e to the x plus e to the minus x times e to the x plus e to the minus x. And then here you'll see that this times this gives me that. This times this gives me 1. This times this gives me 1. And this times this gives me minus 2 this. So with this information right here, I'm going to go ahead and expand this out. So this will be e to the 2x plus 2, e to the plus e to the minus 2x over 4 minus e to the 2x minus 2 plus e to the minus 2x all over 4 equal to 1. Well, since these have the same denominator, I can just move the negative here. And then I can start canceling stuff. So this is a negative e to the 2x, this is a positive e to 2x, these two cancel. This is a negative negative, so this becomes a 4. So this will be 4 over 4. And this is positive e to the 2x minus e to the x, so these two cancel. So that equals 1. So that's how you do the proof. Like you can just plug it in. Or let me show you how to do the other one. So let's do B. So I want 1 minus tangent is equal to secant Okay, so let's look at this. So usually when I don't know what to do for solving these trig identities, I just switch everything to sine and cosine, but these are hyperbolic, so I'm just going to switch everything to hyperbolic sine and cosine. One over cosine. Oops. These squares should be here, not on there. All right, so how would I get this to look like this? Well, here I'm going to work on this side because it's more complicated. So I'm just going to call this the right or left-hand side. Oops. This is the left-hand side. And so the left-hand side, I'm going to put this together. So be one. So this would be 1 becomes cosine squared h, or hyperbolic cosine squared h over squared h minus sine squared h over cosine h. Then here, since they have, so I just took this one and I converted the one into a different one, hyperbolic cosine, just so I have the same, oops, I forgot an h there. Same denominator, then I can put it together. So I have cosine squared, hyperbolic cosine squared h minus sine squared h all over cosine squared, hyperbolic cosine squared h. Well, what's this? Well, this we already established is 1. So this is just 1 over hyperbolic cosine. That's a 1, sorry. And that is equal to left-hand side, so we're done. Okay, so that's kind of how you do the proofs. They're not fun. So here you can either use the definition here, and I like to just use the definition. And in this case, we just use the definition and calculated. We got it equal to 1. Here I said, well, tangent is equal to hyperbolic sine over hyperbolic cosine, so that squared. And then here, this is the more complicated side. I usually take the more complicated side and try to simplify it to get it to equal the less complicated side. Usually what I do. And it usually works out to help. All right. So on top of all this, there's definitions of inverse of hyperbolic functions. So we can have inverse hyperbolic sine and inverse hyperbolic cosine and all this. And so, oops, I forgot my little, there we go. They should have little endings on them. And the inverse functions actually tend to be just this function. And so we can just treat it like this function if we need to. So let's look at the last page. Here we go. And then the inverse functions also have derivatives. Okay. And so these are very much like their other counterparts. They just have different signs and different powers, but they're very, very similar. All you need to know for this class is that it's just another table to look up stuff on. Really, that's all this boils down to. Chapter 3 is, the whole point of chapter 3 is to introduce all these other functions and the derivatives for all these other functions. That way you have a whole menagerie of a function and its derivative, and you just kind of look it up. I mean, by the end of this, you should have like almost 2 pages worth of derivatives. This is this derivative. This is this derivative. This is this derivative. This is this derivative. So, and then we're just going to use chain rule and all this stuff. And so here, we're going to use chain rule in order to do this. So let's do that. So here, we're going to take the derivative of this. So the derivative of this is equal to here, right? And so we'll have 1 over 1 minus sine of x, so sine of x squared, because that's what my x is in this case, we made it to u, times the derivative of sine of x. Well, the derivative of sine of x is, of course, cosine x. And there, from here, your book, if you gave me this on an exam, you get full credit, right? I would say this is fine, right, for the exam. Your book will want to take it one step further. This is equal to, this is equal to cos hyperbolic, or no, this is equal to 1 minus, because cosine squared plus sine squared of x is equal to 1. 1 minus sine squared is equal to cosine squared x times cosine of x. So this is just 1 over cosine of x, which is just secant of x. Okay. I think that's it. I just think that's it. Yeah, that's it, guys.
Professor?
Yeah.
So can you explain again why it's 1 over sine squared of x squared, please?
Oh yeah, so I can do that. So here, why is this cosine? Yeah, so here from our old trig identities, cosine squared plus sine squared x is equal to 1. So cosine squared x, if I'm going to move this to the other side, I'll get 1 minus sine squared x. So if you see 1 minus sine squared x, that's just cosine. Okay? Just comes from the identity.